Hello everyone. So in our last class we have discussed about the force of gravitation. So we had the basic idea what force of gravitation is and how we can calculate it mathematically as per the Newton. And we also discussed about the definition of universal gravitational constant and its value. Today we're going to take on the next topic, that is the gravity. So gravity is what? Gravity is the phenomena of attraction of objects by the earth. So when earth attracts any object, it is said to be in the influence of gravity. And the force which this earth applies, that is known as your force of gravity. Now this force of gravity is that force of attraction that is being applied by the planet earth on any of the object. Its value is given by the Newton in its universal law of gravitation, which was equivalent to capital F equal to G mm over r square. Now here r is the radius of the earth and this F is the force of gravity exerted by the earth. Now we're going to discuss about how this acceleration due to gravity and this gravity force of gravity are being connected. So let's discuss now. So see, look here. As per Newton's law of gravitation, this force of gravity is given by expression capital F equal to G mm over r square. Right? So this relation you have to keep in mind. Now before we move to the next topic which we are about to discuss, let's have a little idea about a free fall. Free fall. Now as the name itself suggests, free fall is falling under the effect of gravity alone. Let's say we have an object. This object is falling freely towards the earth under the influence of no other force but gravity. Then this object is said to be in free fall. So free fall is basically what? Free fall is the falling of objects under the effect of gravity alone. Objects or any other body. If any other body falls under the effect of gravitational pull alone, then the motion is said to be of free fall. Alright, now let's have a relation between this free fall acceleration and the gravitational law given by the Newton. So let's take on. So this was a relation which was given by Newton under the law of gravitation. Now if you remember from the chapter force, we have discussed that force is equivalent to mass of the object multiply the acceleration with which the object is moving. Now let's just try to connect the two. When the object is falling freely, it is falling under the effect of force of gravity. But since the object is falling, so there has to be a force which is acting on the object. Right? So the acceleration we can say, let's replace it with the term g. Why we are replacing with g? Because this acceleration we can define as acceleration due to gravity as well. Because this acceleration was caused by the gravitational pull. So A we have replaced by G. Now these both the forces are defining one and the same thing. This F is telling the value with which this object is falling. And this relation is telling the force with which this object is being acted upon to make such an acceleration. So let's try to connect the two because they both are same. So we can just join them together. Right? Let's cancel out the common term. So we have small g equal to capital Gm over r square. Now just check out this relation for acceleration due to gravity. This value is equivalent to capital G, universal constant, capital M, mass of the earth, again constant, and capital R, radius of the earth, again constant value. Since this small g is depending upon all the constant values, therefore it will also have a constant value. To find its value, just put on the values of all three components. Capital G, that is 6.67, 10 is minus 11, multiply mass of the earth, that is 6 into 10 to the power 24, divided by radius, that is 6,000 400 kilometers into 10 raised 3 meters and whole square. Now using calculator you just solve the value and get the answer as 9.8. So this 9.8 is the value for acceleration due to gravity. So if an object is falling under the effect of gravitational pull, then we have the acceleration of 9.8 meter per second square. Right? So let's move on further. So now we know that the value of capital G is depending upon just on the constant factors. So let's write this again. Small g equal to gm over r square. Now this m and r, mass is about the mass of the earth and r is the radius of the earth. So just see the shape of the earth. Earth is not a perfect sphere, rather it is somewhat oval. So if we say these are the poles, that is North Pole, and let's say this is the South Pole, and let's say this is the equator. Okay, now where you expect the value of acceleration due to gravity will be more? Will it be more at the poles or will it be more at the equator? So you raise the question, sir, that where we have the more distance from the center. Now since the earth is oval, so radius at the pole is less than radius at the equator. Right, so since radius at the pole is less than radius at the equator. Now if radius is less, means our denominator is less, so value of g will be more. So we can say that acceleration due to gravity at the pole is more than acceleration due to gravity at the equator. Gravity at pole is more than gravity at the equator, and the reason is the shape of the earth. Since radius of the pole is less than radius at the equator, therefore we will have more acceleration to gravity at poles in comparison to your equator. Right? So this is how we can say about the variation of acceleration due to gravity as we move on to different points on the planet Earth. Now if I ask you that what will happen to the value of g if you start digging the ground, right? So let's discuss that part now. What will happen if we go inside the earth? Will the g remain the same or will it increase or decrease? Let's try to find the answer to it. Okay, let's do one thing. Let's make out a tunnel on the entire earth, although it is not practically feasible right now at current times, but maybe in future. So let's say we have made a tunnel. A tunnel right across the earth through the center. That's the point of C. This is C, which is denoting the center of the earth. Now, if I say that from the surface, let's say this is your point A and this is your point B. Now, if I say that you start moving inside towards C, let's say this is your position. Let this position be your point O. Now, what do you expect will happen to your small g? Just seeing at the relation, g will remain the constant, of course, m mass of the earth and r is the radius. So will radius increased or decreased as you have moved towards the center? So your answer will be, of course, as the radius has decreased because this is the new r and this was the previous r. Right? Then let's say this is your RO for point O and this be your normal radius r. So this RO will be less than your normal r. So you will say, sir, denominator has decreased, so value of g should also be increased because we have an inverse relation. But it doesn't happen. The g decreases. Now, why so? Because as you have moved inside, the mass of the earth, which is applying the force, this gm, this has also been decreased. Now since the mass has fallen and we have a direct relation between the gravity and the mass, decreased mass has caused a decrease in acceleration. And this mass is such an important factor that as you start moving inside, you keep on going inside, at point center we have small g equal to 0. Yes, acceleration due to gravity at the center of Earth is exactly 0. I hope these things are clear, that what is acceleration due to gravity, how its value can be calculated, and on what factors does it depend, and how it varies as we move up the altitudes or as we move inside the Earth. Right? Let's move further now. Now, what do you expect will happen to the motions of the objects which are having the direct influence under the gravitational pull? How it will vary, or how it will change. So see, let's say this is your Earth. You remember the three equations of motion, right? Those equations were V equal to U plus AT, S equal to UT plus half AT square, and V square minus U square equal to 2AS. Now, these three relations were for the equations of motion. But since here the gravitational pull is in direction and we have the acceleration due to gravity small g here. So let's say how this variation will occur as the object is going upward. Now when the object will go upward, the gravity will always be acting downward. So we can say the first equation will remain as like V is equal to U minus GT. Why minus? Because as you are going up, this gravity gonna pull you down. So we'll have a negative acceleration. Similarly, for the second equation, we have S equal to UT minus half GT square. And for third equation, we have V square minus U square equal to 2GS with a negative sign. Why negative? Because the gravity is pulling down and you are trying to go up. Right? And similarly, as you start a downward motion, the first equation will become V is equal to U plus GT. Why plus GT this time? Because the object is going downward. Second equation will be UT plus half GT squared. Why? Because again you are going down, gravity is supporting you. And third equation, V square minus U square equal to 2GS. So this is how our three equations changes for the upward and for the downward motion. Soon we will be doing the numericals on that as well. So it will make you more clear that how these equations actually changes our answers. Right? Now this was about your gravity topic. So now we are left with just one topic, that is mass and weight, and then we'll start off with the flotation. But before that, we'll be just taking some numericals on this topic. So see you in our next class. In the meantime, just revise the work which we have done today.